As we start topic 8 of chapter 5, Graphing Quadratic Equations, we're going to give you a bit of background information. And as we look at the objectives, find the maximum and minimum values of quadratic functions. This will be background now for this topic. Up at the top of the page or wherever, you're going to write the standard form of the quadratic function. There's the function symbol, there's the quadratic expression, and remember the function symbol can be replaced by a y, and often we're thinking that this y here is 0. So that's some background. Now, when we draw or make a graph of this, these are going to be parabolas. Now the A term, and again, take some notes on this as we go along. If the parabola looks like this, and we say it opens downward. Now, if the A term is a positive, the parabola looks like this, and we say it opens upward. So we'll add a few more vocabulary words. Now, as we look at the parabolas, we see that there is a high point on this one where A is negative, and it would be a point right there, which will be an X and Y coordinate. And since it's at the top, we say this vertex is the maximum, and the parabola, again, opens upward, and at the bottom of the parabola, there is the vertex, and since this is at the bottom, we consider that the minimum. Okay, pause. Be sure you get some good notes on this. Now, to find the vertex, we go to our equation in standard form as best we find it. And actually, it's part of the quadratic formula. The vertex formula is equal to a negative b over 2a. So this will give us our x value of the ordered pair of the vertex. And if we know then what the x value is, if we put that x value into the original equation and solve for y, that will give us our y value. So we'll be doing some examples of this as we go on. All right, adding some more vocabulary. Going to write the word axis of symmetry. Now, when we sketch parabolas, you may or may not have noticed that on one side of it, it's sort of the mirror image of the other side of it. And if you fold it along the vertical line of that axis of symmetry, one side is the same as the other. Now, what is the axis of symmetry? Well, by definition, once you find the vertex, that is your x value in particular, and a vertical line in an equation like this, you may recall, is x equals a, and our a value was the x coordinate. Whatever the x value is in the vertex, that will be your axis of symmetry, and it will be x equals a. And in this case, it looks like maybe x would equal a -1. Now, in this case, the axis of symmetry, again, it would be your x value, and here, I'm just making these up sort of, this would be x equals 2. That would be the equation of this vertical line, which we call the axis of symmetry, which divides the parabola into two equal sides. Another item of vocabulary that we'll be using is finding the zeros. We want you to write this down. And in a sense, we're asking to find the X-intercepts. Now, we've done this in previous sections, where what will be our coordinates when we solve this equation with y equals 0. Now remember, our ordered pair here at the origin is 0, 0. So our y value is 0 at this, where the x-axis crosses. So if we have the standard equation of the quadratic equal to 0, we can find what our coordinates would be. And when we ask this, we'll say find the x-intercepts, which is in a sense finding the zeros. And these will be given as a, 0 for each of these points. And that occurs there as well. Now there's one last thing, and that is the y-intercept, where the parabola will cross the y-axis. Now, again, when x equals 0, we get our y-intercept, which is in this form from an earlier lesson. And you can see how things are building here. So we just take our x as a 0, plot it into this, and that'll give us a value for y. That's our y-intercept. Okay, this is the background information as we go into our actual lessons and do some examples. Now, as we go into the Learn slides, we see they review the linear equation in slope-intercept form, and those would be straight lines. And then they go into graphing quadratic equations, and they're making a t-chart and getting some various points. They're plotting the points, which you'll be doing. They form parabolas, and they go through the vocabulary that we've mentioned. Now, there's the vertex, and we'll figure out algebraically how to find that. And then this dotted line is the axis of symmetry. And as we see it here, it goes through the x-coordinate, which is 1. And we see the symmetry of both sides. Here, this is a properly drawn graph. Now, again, if A is positive, it opens upward, as we see, and that would give us, the bottom of it would be the minimum. Whereas if A is negative, it opens downward, where the top, the vertex, is the maximum. So there's our summary. Now, again, continuing the review in the Learn, and there's the formula for the vertex. Now, I'd like you to take a moment and sketch this. And basically they're showing here that if the A value is, let's say, a fraction, 1/3, the shape of the parabola opens up very wide. Now as it goes to 1, the A value is 1, it gets a little closer to the y-axis. And when its A is 3, it gets rather close. And if it was 4 or 5 or 6, it would get even closer. So this is just trends within the graphing of parabolas. Now, if our parabola, our A value is negative, it's just going to be, instead of going upward, it would go open downward. And again, if it was a negative 1/3, it would be rather broad shaped. A negative 1, it comes in closer to the y-axis, and -3 even closer. This is the A value. Now let me ask a question about this. What is the vertex, just looking at this graph? And if you said 0, 0, the origin, that is correct. Now, what is the axis of symmetry in this graph? It's going to be x equals something. X equals 0 is your axis of symmetry. That is the y-axis. The equation of the y-axis would be x equals 0. Remember, that's from x equals a vertical line, and here x is 0. Okay, just a little review. Now, for example 1 in your notes, and we'll go back to red. Here, they're giving us, using a y, but we could substitute the f of x, and it's in standard form. So we're asked to find the vertex. Well, our vertex formula is this, so we substitute. Now, as we look at the equation here, there is no b value. So b is 0 over 2 times 1 is 2. So 0 divided by 2 is 0. So for part of our vertex, that's going to be 0. Now if x is 0, what is my y? Well, where the x is, right there, you put in a 0. So it says y equals a -1. Ah, that one was easy. Now, what is our axis of symmetry? Well, we had said the axis of symmetry is our A value in the ordered pair, that is the x coordinate. So here, our axis of symmetry is going to be x equals 0. Now, for our x-intercepts, we're going to say that 0 equals x squared minus 1. Now, the text does this another way. We could also use the tool of this factors into its conjugates, x plus 1, x minus 1. So here, x is going to equal a -1, and x would equal a +1. But remember, that's only the x coordinate. So this is going to be a -1, comma 0, and this will be a +1, comma 0. You have found the zeros. This is finding the x-intercept. Now, what is the y-intercept? Now, for the y-intercept, we already know that we have some value of a, and that is a 0. And if you recall, the y-intercept is written 0, comma b. Well, in this case, it happens to also be the vertex. So the y-intercept is 0, comma, -1. Now, if we take all of this data and then find some other points, and as we go down, they make the graph, making a t-chart, and we'll clear this up so you can see it better. There's your vertex. Axis of symmetry is x equals 0. And then these are the zeros. This is this ordered pair and this ordered pair. Now they found some others, so we get a general shape of the graph, and you'll be doing that. And there is a graphing tool in the software where you, not a straight line, but you pick a parabola and then plot and shift it and move it and put the points in. You'll have to get some hands-on experience of that. Okay, example 1. In example 2 now, again, there's the quadratic function that I've written up. We want to find the vertex. So here, v will equal a -b. Now, b is -6, so a -b is a +6. And then a is 1, so 2 times 1 is 2. So our x value for the vertex is going to be 3. Now, here to find the y-coordinate, if we put 3 where the x is, and we'll do some substitution. So 3 squared there, minus 6 times x, which is 3, plus 1. This is 9 minus 18 plus 1. That'll be 10 minus 18. That's going to give us a -8. So there is our vertex. Now, what is the line or the axis of symmetry? Well, again, it's the x-coordinate of the vertex. So that's going to be x equals 3. Now, what are the zeros? That is, the x-intercepts. Well, to save a little time, I'm just going to go down and show you how they figure them out. And there they are right there. You had to use the quadratic formula, which we had in a previous lesson, substituting. And again, these are ordered pairs. Let's see if we can pick them out here. That this is the x value, and then comma 0. This is the other x value, comma 0. And these are the zeros. So sometimes it's a challenge to do that. And for our work here, you can just write these in. You don't have to do the quadratic formula on this, but when you do it, of course, you'd have to write it in. And then for the y-intercept, and let's look at this here to help us. Again, the key to the y-intercept is that x is now going to be 0, and you want to find what your y-coordinate is. So where there's an x, you put a 0. Where this other x is, you put a 0. So these two are zeros. So your y-coordinate is going to be a 1. So that's for letter D. Hopefully you're organizing that. Now as you graph this, and we'll clear that up. Again, you use a T-chart, get some points, and you see there is 1 point, one ordered pair, and there's the 0, and then the other ordered pair, and then there's the 0, and then there's your vertex. Now we said the axis of symmetry was whatever the x coordinate is, that would be x equals 3. So we found the vertex, we found the axis of symmetry, we found the zeros, and we found the y-intercept right over here. That's nice. That was 0, 1. So again, sketch these graphs as well, and you can see as a model when you get to do these in your practice and certify. Going on now to example 3. Here's the quadratic function. Notice they switch off from y, and f of x can be replaced anytime. Now notice our a value here is negative. So here the parabola is going to open downward, and our maximum is the vertex. So let's find the vertex first. So we have a negative b. Now b is 4, so a negative b would be a negative 4. And our a term is negative, so negative 2 times 2 is a negative 4. So our vertex is going to be a positive 1. Now, if x is 1, what is our y value? Well, it's going to be a negative 2 times 1. You now know x is 1, that we're going to square, plus 4 times 1. So we're just substituting the x value that we found from the vertex to find our y coordinate, because this is y. Y equals this. So this is going to be 1 squared is 1. Negative 2 times 1 is 2, negative 2, plus 4, and this becomes then a 2. So our vertex then for this, and this would be the maximum, because a is negative, it's going to open up downward. Now, what is our line of symmetry? The axis of symmetry. Well, it's whatever the x coordinate is. So x equals 1. Now, what are our x-intercepts? Well, we're going to take this equation, negative 2x squared plus 4x, and equal it to 0, because our coordinates are when something like this. We're looking for the zeros here. So using a technique from an earlier lesson, we can factor out a negative 2x out of here, and this then becomes x plus, or I should say a minus, two equals 0. And we can distribute to see that we've got it right. Okay, so now we're going to equate each of these factors to 0. So this one is 0, and this one is 2. So our x values, solving this using factoring, is going to be a 0 and a 2. All right. Now, what will be your y-intercept? Well, again, you're going into this original equation, and you're saying, again, your y-intercept is 0, comma b. If x is 0 here, this becomes a 0, this becomes a 0. So the y-intercept is the origin, 0, comma 0. All right, now let's take a look at what the book is showing us, because they do a nice job too. And I'll clear this up here, so hopefully you have it written down. So we got the vertex, 1, comma 2. Got the axis of symmetry is x equals 1. We solved it using factoring, and we got, for our x coordinates, this. Now remember, when we're finding the zeros, our y coordinates are 0. And then our y-intercept is the origin, and we showed you how to get that. And then now here's the graph. So the vertex is a maximum because A is negative, it opens downward. There are our zeros, our x-intercepts, and this is also our y-intercept here as the origin. So again, sketch this. Many quiz questions in here, but if you have it already done and there's an understanding, that's going to be what we're looking for. Well, we're 26 minutes and we're only halfway through, so this was a rather challenging of all our lessons so far, where we've pulled in lots of stuff we've used and build up toward this point. So we will at this time end this part. This will be part 1. And then in a little while, we'll start part 2. Give you a little break between our lessons.